The conquest of space required the establishment of a gigantic technological infrastructure. In the United States, NASA acted as an intermediary between the government and large space companies. More than 90% of NASA's budget was channeled to private companies, which carried out these space projects. The Apollo project was the largest government venture in American history. Tens of billions of dollars were invested and allocated to hundreds of companies specializing in high technology. By the end of the 60s, more than 300,000 Americans were directly involved in the U.S. space program.
Launch commit, liftoff. We have liftoff 49 minutes past the hour.
The large scientific space exploration projects demanded sizable investments. The Viking project to Mars in 1975, for example, cost more than $1 billion American dollars.
Touchdown win. Fantastic object. It's 16 kilobits.
The construction of the space telescope was also expensive. It cost more than $1.5 billion American dollars. The commercial and industrial spin-offs, however, were just as profitable. Costing close to $10 billion American dollars, the building of the fleet of American space shuttles followed a similar pattern of development. A California-based multinational, Rockwell, was placed in charge of constructing the fleet of shuttles. The company was also in charge of integrating components produced by numerous other companies that had been subcontracted to look after the smaller details. In all, tens of thousands of workers from hundreds of companies participated in the construction of the shuttle. The launching of the shuttle program in 1972 was a turning point in the conquest of space. For the first time, it was hoped that a space system would finance itself from commercial revenues. Economically, the shuttle program was an appalling failure. The estimate of one shuttle mission was around $15 million. In reality, it ended up costing 10 times as much. There were not nearly as many missions as had been anticipated. The first fleet of 4 shuttles was to carry out over 40 missions a year. In 1985, the best year, only 8 missions were launched. To make the shuttle commercially viable, the American authorities decided to gradually eliminate conventional rockets altogether and to use the space shuttle for launching satellites. Since the shuttle reaches an altitude of only several hundred kilometers, An auxiliary propulsion system was required to place the satellites into their final orbit. Besides increasing launching costs, this non-recoverable system complicated the maneuvers required for placing satellites in their final orbit. It also increased the risk of technical problems. There were consequences. During the Challenger mission in February 1984, 2 communication satellites were lost, one after the other, when the auxiliary launching system attached to each satellite malfunctioned. The loss of the satellites wasted more than $200 million and undermined the credibility of the shuttle as a launching instrument for geostationary satellites. Another very large satellite, the TDRS-A, was almost lost in April of 1983. Once again, the auxiliary launching system was responsible for the near failure. The system, designed by the Department of Defense for heavy satellites, had to be re-examined. This resulted in the postponement of several important military missions.
And it has cleared the tower.
Roger, roll, Challenger.
The Challenger disaster in January of 1986 sealed the fate of the shuttle's commercial viability.
We'll throttle down to 65% shortly.
In addition to destroying one of the 4 space vehicles, the terrible accident saw the 3 other vehicles confined to the ground for more than 2 years.
Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical miles. Engines throttling up. 3 engines now at 104%. Challenger, go with throttle up.
The cost of technical modifications, combined with added safety measures, eliminated any hope for the commercial viability of the program. The construction of one new shuttle would now cost $3 billion US. NASA was forced to choose between the shuttle and a return to more traditional launchers. A wide range of impressive American rockets destined for the junkyard as a result of the shuttle were once again being considered for service. The Titan, Atlas, and Delta rockets were put back into production in order to fulfill the still outstanding commitments worth billions of dollars. When conventional rockets began to take over from the out-of-breath shuttle, they were plagued by bad luck. (1986) was a black year for NASA. 2 rockets, a Titan and a Delta, failed to place their satellites into orbit. After that, all American launchings were grounded until an explanation for the failures was found. If bad luck had not also affected the Europeans, they would have seized the opportunity to promote their Ariane rocket. European promoters had been locked in a bitter fight with the Americans for several years. But on May 30th, 1986, an Ariane rocket failed, resulting in the loss of an Intelsat satellite worth at least 55 million American dollars. It was the fourth failure out of 18 launchings of the Ariane rocket. In comparison, the American Thor Delta rocket failed only 10 times in 177 takeoffs since 1960. The string of failures in 1985 and 1986 proved a harsh blow to the companies that risked insuring the satellites. Over the course of 2 years, these companies had to pay over $1 billion in damages. For these 2 years alone, the payments exceeded the total of all premiums collected for all commercial launchings since the beginning of the program. This string of disasters discouraged the majority of insurers, and they no longer wanted to provide any coverage. As a result, the manufacturers of the satellites and the launching agencies had to supply their own insurance. The competition between the Europeans and the Americans will be very lively once they start using conventional launchers again. One could expect another price war, like the one which took place between NASA and Arianespace a few years ago, when the Americans and Europeans accused each other of unfair practices. Each side claimed the other was setting prices lower than the actual cost of the launchings. Arianespace's marketing strategy has produced results even in the United States. The American consortium, GTE SpaceNet, has used Arianespace to launch 5 of its communications satellites. The development of a national space industry is an economic reality which no developed country can afford to overlook. In 1984, the space industry employed more than 30,000 people. A third of those were employed in France. Before the end of 1990, the industry will probably provide another 100,000 jobs directly related to the industry. By then, the industry's annual sales should reach 5 billion American dollars. These sales will have a fundamental effect on the economic development of the countries concerned. The telecommunications market alone generates sales over 3 billion American dollars just through the operation of its satellite networks. The manufacturing of technical equipment has even greater economic potential. The German consortium, GUSAT, has been established with a view to developing a new family of telecommunications satellites specially designed for third world countries. The system requires an initial investment of approximately 400 million American dollars, which will be recouped through sales when the system is manufactured in series. Remote sensing is another example of the developments taking place in space technology around the world. For years, the Americans were the only ones to offer remote sensing images to Western countries. By developing the SPOT system, the French have provided an alternative to clients who use remote sensing. The operation of the American Landsat remote sensing satellites has been taken over by a private consortium. Called EOSAT, the consortium intends to compete directly with the French on the international market. The Europeans are no longer the only ones standing up to the Americans in the space industry. Several years ago, Japan initiated a space program very much inspired by the Europeans. They already have relatively reliable launchers, which will eventually claim a portion of the international market. Japanese companies have also proved they are capable of building their own satellites, either in whole or in part, and they are offering their services all around the world. India, too, has been pursuing an ambitious space program, and China is offering to launch Western satellites into orbit. The Soviets didn't seem to be interested in venturing outside the socialist bloc. However, they've been investing heavily in a diversified space industry which might one day occupy a prominent position in international economic affairs. The second phase in the commercialization of space will begin once the industry learns how to exploit the physical advantages of being in space. Weightlessness, or microgravity, provides the opportunity to produce an unlimited variety of chemical and physical reactions which are impossible to create on Earth. American experts have gone so far as to predict industrial application of space will bring in annual sales of more than 50 billion American dollars by the turn of the century. Experiments carried out aboard the American Skylab in 1973 provided an insight into the technological advantages of weightlessness. Free from gravity, astronauts produced alloys in a small metal oven, which would have been impossible to manufacture on Earth. Space conditions are perfect for the production of exotic crystals, which could be used profitably in microelectronics. "36 meters long, this fantastic laboratory is the largest space station ever launched. Unfortunately, Skylab was ahead of its time. The cost, more than 2.6 billion American dollars, was never recouped. The lab was abandoned in space after 3 Skylab missions. Costing more than 150 million American dollars per mission, Skylab was too expensive to be used regularly. If the space shuttle had been ready on time, the space station could have been brought back into its orbit and saved from destruction. Unfortunately, that was not to be. The Skylab disintegrated in the atmosphere over Australia on July 12, 1979.
The tower is clear.
And we have a roll program. Roger.
While waiting for a new permanent space station, the Americans continued their experiments aboard the space shuttle. Over the last few years, McDonnell Douglas and NASA have been working together in an effort to produce medicines in space. The American company even paid $80,000 so one of its employees could oversee the experiments. An engineer, Charles Walker, participated in 2 missions of the shuttle Discovery in August of 1984 and April 1985. Problems with the shuttle, however, forced McDonnell Douglas to revise its production schedule. McDonnell Douglas was trying to develop an automatic production system which could be carried on board a future American space station. This type of automatic platform was tested in June of 1983 during the shuttle's 7th mission. Developed by German researchers, the mini lab weighed 2 tons and was left in space for several hours before being recovered by the shuttle's remote manipulator and returned to Earth. The following April, a giant 10-ton platform was sent into orbit. The long-duration exposure facility was used to analyze the behavior of materials and experimental automatic systems left in space for long periods. The platform was to be recovered a year later. Unfortunately, it's still in orbit, and it's unclear whether it will ever be retrieved. This last experiment was one in a series which must be completed before a permanent space station with platforms for manufacturing new products can be constructed. For the moment, all projects in the West have been delayed because of the setbacks suffered by the American space shuttle. The Eureka, a European automatic platform, was supposed to be launched in 1987 or 88 before being integrated into the proposed American space station. The launching of the space station has been rescheduled for 1996. Many experts, however, have openly admitted it will not be operational before the year 2000. Maybe, by then, the space industry will be able to start paying back a portion of the hundreds of billions of dollars that have been invested during the last quarter of a century.